Hello everyone, welcome back. In the previous video, we learned how to integrate a large language model with the MCP tool along with some associated security considerations. Today we are wrapping up our MCP basics series. In this final video, we will cover what we didn't cover in the previous videos and why. And second, the future outlook of MCP and related approaches. Let's dive in. So far in this series, we've explored many aspects of MCP. First, why MCP was developed by understanding the concept of tools and how AI models can call them. Second, basic MCP concepts such as clients and servers. Third, how to create an MCP tool and how to call it and connect it to an existing MCP server. First, how to integrate MCP tools with large language models. However, even in this final video, there are still some topics we didn't touch. Before closing the courses, I'd like to let you know one important concept: resources. Resource is similar to a tool, but there's a key difference. It doesn't perform significant computations. You can think of it more like a structured piece of data. According to the official documentation, resources are how you expose data to LLMs. They provide the information without performing major computations. Conceptually, this makes them quite different from tools. So why didn't we cover everything? First one is focus on the essentials. For beginners, it's easier to start with the most important concepts. Covering too much at once can be overwhelming. Second, you are ready to explore further. By now, you understand most of the core MCP concepts. This foundation makes it easier to read the official documentation or explore advanced topics on your own. Let's recap how traditional MCP tool calling works. First, the LLM generates a JSON formatted output containing the tool name and arguments. Second, the MCP client sends this JSON to the MCP server using the JSON RPC protocol. Third, the server executes the tool and sends the result back to the client. Fourth, the MCP client inserts this result into the LLM's context. Fifth, the LLM continues generating output based on this updated context. This method works well, but it's not the only way to call a tool. A newer approach is called ACT, which leverages the LLM's ability to generate executable code directly. Here's the idea. Instead of relying on human-defined tools, the LLM generates Python code to solve a task. For instance, when user asks, please analyze the CSV file located at this, the codec agent will generate the answer. First, to accomplish this task, I will use the pandas library, blah blah blah, and it will also generate some Python code block. The above generated code is executed by a Python interpreter, and the results are fed back into the LLM's context. The LLM then generates the next step to complete the task. Interestingly, the authors of Codex suggest that this approach can outperform traditional JSON-based tool calling. Frameworks like LangGraph and Hugging Face's agent library are starting to support Codex-style agents. One important note, MCP is built around the JSON RPC to standardize tool calls, whereas Codec may require a different protocol since it doesn't require JSON formatting for tool calls. Instead, it requires a Python interpreter. Actually, tool calling is still an active area of research. We are only just beginning to explore how to use tools with LLMs effectively, and in the future, the methods and standards could look quite different from what we use today. To summarize, we've covered all the core MCP concepts you need to get started. Second, LLMs are evolving to handle code execution tasks directly as seen in CodeAct, which could influence future MCP-like framework. That's it for the MCP Basic series. Thank you for following along, and I hope you're ready to explore advanced MCP topics and other next generation LLM tools. Thank you, goodbye.